Hello, my name is Ellie.
And my name is Michaela, aka Mack-N-Cheeze.
And our science fair project was over landslide prevention.
Or prevention landslide.
Because we glued it on wrong. But that's okay. Okay, so our problem/question was landslide prevention, hence the name.
Our hypothesis was if we put the test all the ways to prevent landslide, then we know that plywood worked the best.
And our variables were that our independent variable was a way to keep the sand from sliding, would normally be the dirt, the earth, in like a real situation. And then our dependent variable was the topsoil and the sand. And it was topsoil and sand because we brought in topsoil and sand and we mixed it all in a big box and then we shoved it in our shoebox.
Our material list is plywood, netting, topsoil, sand, a shoebox, and wooden dowels.
And then our data table was that the netting held dirt the second best and had 50 milliliters of dirt spilled out of the shoebox. What would mean that it spilled out of the shoebox was that it came out of the wooden dowels or netting, in this case netting, so all the dirt leaked out of the netting. Okay, then plywood held dirt the best and it had 0 milliliters of dirt spilled. And then our wooden dowels held dirt the worst, and it leaked 250 milliliters of dirt. What we mean by all the things is that, there is the plywood shoebox, there is the wooden dowel shoebox, and here's the netting. So for the wooden dowel shoebox, all we did was shoved wooden dowels through the shoebox and then filled it with dirt. And then for netting, all we did was hot glue the netting around the shoebox and then filled them all with dirt.
And our other graph is that we use this graph because we liked how it represented all the things. And the blue is wooden dowels, the pink is the plywood, and the purple is the netting, as you can see.
And then, I just clicked the board. And then our procedure was that we cut wooden dowels and put them in the shoebox and then filled it with the topsoil sand mixture. And then we cut the netting and put it around the shoebox and hot glued it, or super glued it, I kind of forget, and then filled it with the topsoil and sand mixture. And then we cut the plywood and put it inside of the shoebox and put hot glue around it. And then we filled it with the sand and topsoil mixture. And then we took a little spray bottle and we sprayed 20 squirts of water in each shoebox.
Our conclusion is we did our science fair project over different methods to prevent landslide. What ended up happening is that the plywood worked the best because none of the dirt leaked out. Our hypothesis was the plywood worked the best, so it was right. Our hypothesis was supported because the plywood was the best.
And then our science fair abstract paragraph was that our project's purpose was that I wanted to do something kind of weather related, and Mac wanted to build something, hands-on build something. And then our other reason to do a landslide prevention was because I wanted to see what engineering worked best. I also wanted to see the engineering behind it because my uncle lives in California and they have a lot of landslides, so I wanted to see how they were doing it there and how we were doing it and what worked best for us and what worked best for them. And what they end up doing is they take this orange kind of netting, and it has a 1 centimeter by 1 centimeter hole in it, and it keeps the dirt pretty well, but they still have landslides obviously, so it doesn't completely hold it.
I know that a landslide is a movement, rock, debris, or earth downslope. Independent variables The way to keep the dirt in the box, dependent variables, the amount of land that slid out of its spot. Our hypothesis is if we tested all the ways to prevent landslide, then we know that plywood worked the best.
We did our experiment by cutting wooden dowels and putting them in a shoebox, filling the shoebox with sand and topsoil, cutting netting, putting it in the shoebox, filling the shoebox with sand and topsoil, and cutting plywood and putting it in the shoebox and filling it with sand and topsoil. And then we sprayed 20 squirts of water in each box.
The data table told us that 50 milliliters of dirt spilled out the netting box, 0 milliliters of dirt spilled out of the plywood box, and 250 milliliters of dirt spilled out of the wooden dowel box. We did our science fair project over different methods to prevent landslides. What ended up happening is that the plywood worked the best because none of the dirt leaked. Our hypothesis was that the plywood would work the best, so it was right. Our hypothesis was supported because the plywood was the best.
So that was our science fair project.
Yep. Beautiful.
And, so, bye-bye.